Subha madam, start madam.
A very good morning to one and all present here. It gives me immense pleasure to extend all of you a very cordial welcome on behalf of R.M.D Engineering College for the Generic Talk Series 18 on Membrane Technology for Sustainable Development of Indian Industry and Society by Dr. S. Sridhar, Chemical Engineer and Scientist, CSIR, Indian Institute of Chemical Technology, Hyderabad. Well, membrane technology plays a crucial role in the sustainable development of Indian industries and society by offering efficient, cost-effective, and environmentally friendly solutions for water purification, wastewater treatment, energy production, and resource recovery. Today, we shall enlighten ourselves with a broader perspective and listen to an eminent speaker. I take the pleasure in inviting Dr. P. Kamalarajan, Assistant Professor, Department of Chemistry, to welcome the gathering. Please, sir.
Thank you, ma'am. A very pleasant morning to everyone present here. It's my pleasure to be a part of this event and to deliver the welcome address. On behalf of our management, Honorable Chairman, respected Vice Chairman, Director, Advisor, Principal, Dean, Heads of the Department, I welcome our esteemed guest, Dr. S. Sridhar, Chief Scientist at CSIR, Indian Institute of Chemical Technology, Hyderabad, for a generic talk series 18 on the topic Membrane Technology for Sustainable Development of Indian Industry and Society. We are honored to welcome our esteemed guest today. Despite of his busy schedule, he has graciously accepted our invitation. Thank you, sir, for accepting our invitation to share your expertise with us. It is truly an honor to have you here today. A warm welcome to our HOD and Heads of the Chemistry Department, Dr. K.S. Radha, Head of the Physics Department, Dr. R. Priya, who support us, encouragement, have played a vital role organizing this event successfully. I sincerely welcome all heads of the department, professors, faculty members, participants, and dear students. Your presence and active participation make this talk series as a meaningful and enriching experience. I would also like to express my gratitude to our management for providing us with this wonderful platform, the Generic Talks series, which enabled us to engage with distinguished resource persons, gain encouragement, and stay updated with the latest advancement. Once again, a very warm welcome to our esteemed guest today. Sir, it's a great privilege to have with you us. I hope all our faculty members and students will make of the most of this opportunity. Thank you, sir.
Thank you very much, sir. Thanks to R.M.D College and all the faculty and Radha Madam for inviting me, the HODs, all the teachers. Thank you very much, sir.
Thank you, sir. I feel greatly elated in inviting Dr. K.S. Radha, Professor, Division Head Chemistry, R.M.D Engineering College, to introduce the chief guest. Please, ma'am.
Thank you, Subha ma'am. Good morning to one and all present here. I am immensely honored to introduce our chief guest of the day, Dr. S. Sridhar, to all of you now. Dr. S. Sridhar is a chemical engineer from College of Technology, Osmania University, Hyderabad, who has been working as a scientist in the area of membrane technology at CSIR IICT Hyderabad for the past 27 years. He is presently a chief scientist there. He has developed and transferred several technologies for chemical and allied industries, besides having contributed immensely to rural welfare through water purification projects and face mask design and academic progress via extensive HRD and lab development in several schools and colleges. Major highlights of his career include the commissioning of several membrane pilot plants based on electrodialysis, nanofiltration, gas permeation, and reverse osmosis, and even in pharmaceutical, steel, textile, aroma chemicals, and petrochemical industries. He has designed and installed more than 70 water purification plants based on nanofiltration, ultrafiltration, and reverse osmosis of 600 to 4,000 liter per hour capacity for purification of groundwater, surface, and floodwater for 5 million population affected by fluorosis, gastroenteritis, jaundice, typhoid, and other waterborne diseases in 10 states of India. Free water camps based on compact system design were established by Dr. Sridhar in Hyderabad city, besides industrial and science exhibitions for the urban population, including pedestrians, drivers, and commuters of public and private transport to provide a safe and healthy water free of cost since April 2016. Other innovations include a novel and affordable system for medical grade water for dialysis of more than 2 lakh patients suffering from chronic kidney disease in Nephroplus, ESIC, and Nilofer hospitals, apart from developing a prototype hemodialysis membrane module as an import substitute. He has designed an atmospheric water generator of 60 to 1000 liter per day capacities to produce remineralized drinking water from relative humidity in the air in water scarce regions, coastal belts, border areas, hospitals, and railway stations. For mitigation of COVID-19, Dr. Sridhar designed novel multi-layer masks and face shields that were provided free of cost to more than 6 lakh population, including school children, police personnel, doctors, nurses, and healthcare workers, village folk, orphanages, and old age homes. He designed a low-cost device for producing alkaline ionized water that is an immunity booster. Dr. Sridhar is an all-round sportsman who captained cricket, lawn tennis, and football teams at the state, university, and all India CSIR level sports competitions, besides excelling in badminton, table tennis, and chess. Dr. Sridhar has published 185 research papers in reputed international journals such as the Journal of Membrane Science, Industrial and Engineering Chemistry Research, and Macromolecules, which are widely cited by peers more than 11,400 times with an H index of 54. He is ranked among the top 2% scientists in the world by Stanford University, USA, and Elsevier Science Publishers in 2001 to 2024. He has 20 patents at his credits, 4 books, 51 book chapters, and trained 500 BTech, MTech, and MSc students from different universities and guided 14 scholars for the award of PhD. Dr. Sridhar is a recipient of more than 75 prestigious science awards, including 35 national awards, 3 state awards, such as CSIR Young Scientist Award 2007, Engineer of the Year Award 2009, Scopus Young Scientist Award 2011, and NASI Reliance Industries Platinum Jubilee Award 2013, VNMM Award from IIT Roorkee 2015, 5 SIPET National Awards for 2016 to 2020, Nina Saxena Excellence in Technology Award from IIT Kharagpur in 2017, Director Special Appreciation Award 2020 for contributions in COVID-19 projects, CSIR CAIRD National Award announced on 26 September 2020, 3 HPCL NGIC Awards for 2019 and 2021, IICH Jubilant Award, Asokam Award in 2023, and FRSC in 2024. Such a versatile and eminent personality is amidst us today to share his expertise and knowledge with us. Thank you, sir, for being here. We are really proud to be listeners of your speech today. Thank you, sir.
Thank you. Thank you, madam.
Thank you, ma'am. I feel privileged to invite our distinguished chief guest of the day, Dr. S. Sridhar, chemical engineer and scientist, CSIR Indian Institute of Chemical Technology, Hyderabad, to address the audience. Over to you, sir.
Thank you, madam. Thank you very much. Thank you for the generous introduction as well. I hope the screen is visible and I'm audible.
Yeah, it's visible.
Yes, sir.
Yeah, so I'll take you across my brief journey, briefly this long journey of nearly about 30 years. So in October, I'll be completing 30 years at CSR IICT, including 27 years as a scientist. And we have ventured into different areas of research, and also I felt that whatever we do should go to the society. So in this context, I've made the presentation, and I'm really very happy to have been invited by R.M.D Engineering College for giving this presentation. So when I joined IICT, my vision was to promote science and technology for industrial growth, so solving challenging separation problems such as azeotropic mixtures. As we all know, ethanol water, it forms an azeotrope. Isopropanol water also forms an azeotrope. So separating those components was a challenge. And then also we had a project with Vikram Sarabhai Space Center for separating hydrazine and water. So it was a little bit of a risky separation because of the explosive nature of hydrazine. So dehydration of hydrazine to up to like at least 50-50 mixture, if not more, was one of the objectives. And then desalination of the propellant reaction liquors of monomethyl hydrazine and unsymmetrical dimethyl hydrazine was also carried out up to the laboratory level there. And then we have this effluent treatment, wastewater treatment. So now it is the era of zero liquid discharge, and industries are not supposed to dispose anything into the soil or into the water bodies nearby, because it will cause huge contamination. So they can at best send some solids to landfill, and even there are problems like landfill leachate and those things. So industries have to see that they don't send any liquid effluent out. They have to treat it inside and reuse the water. So we had been working on this context as well. And then societal welfare came naturally because nearby Nalgonda district was suffering from a lot of fluorosis problems, like so dental weakening of the dental and the framework, and also the knee joints and the entire skeletal frame. So that was one of the problems faced by Nalgonda, then Warangal, Prakasam districts. So both Telangana and Andhra Pradesh have had this problem since decades together. So we set up some model plants so that those plants can be followed. But we have to remember that the reject water has to be also treated and reused. Then only it is a complete solution. So in our homes also, I would like to request that the reject water from our domestic RO systems, in case they are being used, so that also has to be used somewhere for laundry or restrooms or something. It has to be reused and not wasted into the drain. And then later we moved on to nanofiltration, because reverse osmosis is not required where we do not have like saline water or arsenic or fluoride contamination. So we can do with nanofiltration, which is a process that lies between RO and ultrafiltration. And here nanofiltration, the pore size will be 2 to 5 angstrom units. So whereas RO is 1 angstrom unit, so it is slightly more open, 2 to 5 times more open than RO. And so we get more minerals in the permeate, and therefore we don't have to look into remineralization by using a bypass stream like we do in RO. So RO also, if you're having systems at home, we must use this TDS control valve. Ask the supplier or the engineer who comes for servicing to show the TDS. At least 100 to 350 range is required for healthy mineral water. For especially for municipal water, we actually don't require RO. We can manage with nanofiltration or even ultrafiltration, because the TDS is also already less than 500 ppm, which is the specified limit of BIS. This is all provided the water has no arsenic and fluoride. So municipal water will not have. So we can treat it with ultrafiltration followed by UV, and the water is very rich in minerals, and we can consume it. If you already have RO, then ask the supplier to provide a blending line which goes after the pre-filters and bypasses the membrane and then mixes with the membrane permeate. So 10% of this water goes with 90% of the RO permeate, and then both together go through UV so that there is no bacterial contamination and or pathogens, and then both together will go through UV. And then for improved taste, we can also have an activated carbon column in the permeate line as well, not just in the feed line. So activated carbon column will improve the taste. So in this way, we can handle the RO systems that are already existent and see that it provides sufficient minerals through this remineralization technique. And then we also move to biomedical applications. So providing medical grade water. So this had come when our chemical biology division of IICT came to me in 2015 saying that some of the imported systems are not working. They were purchased for large sums of money, and they are lying waste, and there is nobody to service. The AMC is also very expensive, 1 lakh per annum, and the system cost is 3 to 5 lakhs per annum. And both equipment and cultures, the microbial cultures, were getting damaged. So they asked me to find a solution. So I gave them a solution, which we will see in the forthcoming slides, a double stage RO using hydrophilized polyamide membrane, which is the more the hydrophilicity, the less the fouling, followed by resin and then UV treatment. And without any intermittent pump for the second stage, we gave this simple design, which costs only about 30 to 40,000 rupees, and it has been working very well since the last 10 years. And then the human kidneys, as we know, is the most selective membrane, and dialysis, we you can see in the screen, dialysis membrane itself. So that membrane, like using polysulfone hollow fibers, we have been making attempts, and we have to soon scale it up and then see go for certifications to see whether we can reach out to the common man at a lower cost compared to the, now again it is being imported from several countries. So that is the thing. So academic progress, of course, wherever I have gone, I want to develop the lab there so that students will have sufficient infrastructure for doing their PhD and dissertation work, be a BTech, MSc, and MTech dissertation work. So that is there, and already I think R.M.D college is doing a great job as far as HRD is concerned in training students and for BTech and other engineering branches. So that is how it began. Then how to respond to disaster. So like COVID-19 and floods, I will show through some videos. So ladies and gentlemen, as we can see, the causes of global warming and their mitigation. So most of the plants are like coal-fired power plants, which so as an alternative, we need to go for renewable energy resources such as electrically driven vehicles in the future. And as far as power is concerned, you can go for solar energy or even hydrogen as a fuel, or wind energy. So these kind of renewable energy resources have to slowly replace some of the fossil fuel based plants, because, or not only because of the depletion of the fossil fuels, but also because of the huge emission of carbon dioxide and other heat trapping gases, greenhouse gases we can say, which go into the atmosphere and then heat up the temperature by absorbing the infrared radiation from the sun. Agriculture, well, if we go for organic farming, we can avoid that nitrous oxide N2O, which also is a heat trapping gas. And as we know that agriculture is one of the most widely like used source of employment. So a lot of fertilizers, they will be containing, they will let go of nitrous oxide N2O, which will absorb IR radiation. So better to go for organic farming and sustainable agriculture. And as I have already said, vehicles which are like electrically driven and fuel cell driven, to avoid both noise pollution as well as the SOx and NOx pollution and carbon monoxide pollution that can be caused by the present vehicles that run on gasoline and diesel. And we must avoid excessive industrialization and production so that we can save energy. And even landfills, they give out CO2 and CH4, which are both again contribute to global warming. And we and students especially have a very major role to play to spread awareness to avoid the wastage of water and food as well, because a lot of energy goes into making purified forms of these. And if we are able to reduce the wastage, then indirectly we will be saving a lot of energy, which again comes from the coal fired plants and those kind of things. Industrial effluents, I already discussed about the treatment and promoting zero liquid discharge. So even offshore oil rigs fracking also produces a lot of CO2 emissions. So afforestation is very important, and so that we need to plant more and more trees to tackle global warming from now itself. So I will give brief case studies on each area. So propane propylene separation in petroleum refineries, C3 splitter is the tallest column, and then some technologies for CO2 capture, then videos on flood response and mitigation of water scarcity. So if we do not have any water, what do we do? Then applications, in quickly I will cover applications, food and health sector, effluent treatment, one or two case studies, and then one case study on COVID-19 challenges and future prospects. So as we can see here, we have got the several case studies are here. So one is the mask that we had made, and so that was a washable mask with two intermediate layers that were hydrophobic. Because of the hydrophobicity, like lotus leaf, like the droplet sits on the lotus leaf, the respiratory droplet will not be able to penetrate these two layers. One layer is a membrane extract, like extract from a spiral module, that is a ethylene terephthalate layer that is used as a permeate spacer, and the other is a very ultra thin polypropylene layer. So these two hydrophobic layers will prevent the entry of the respiratory droplets, because as per Young Laplace equation, higher pressure is required when the contact angle is high, and also the porosity is not linear, so it is like tortuous path. So that is another thing that helps. And so in this way, this mask was made, and it has resulted in 500 people being employed during COVID, and generated a revenue of about 2 crore for the NGOs who have taken this technology from IICT. And on the right side, you can see an effluent treatment plant. I will go more into detail during the case studies. And we have got some free water camps also running, as we can see at the bottom of the slide. So these are some of the recent projects. One is, like you can see, the effluent treatment plant, where high pressure RO is done to separate the esters. Like for example, isoamyl acetate, it's a banana flavor. So these UK aromatics, they make artificial flavors and fragrances, and which are exported. And the condensate of the evaporator, multiple effect evaporator, still contains a lot of COD in the form of these esters. And high pressure, the higher the pressure of the RO system, the better is the rejection, because of the solution diffusion mechanism, water will have the water flow will increase, whereas that of the solute, like these esters, will remain more or less the same, because there is no interaction between the esters and the membrane, whereas the membrane is polar, and it is has affinity to the hydrophilic water molecules, which will diffuse, and moreover they are smaller molecules, so the diffusion coefficient will be higher. So we'll get better rejection towards the esters, and higher permeation of the higher flux of the water. And here you can see the flood response in this is in Gokak in Karnataka. So when there, in the absence of electric power, we use hand pump driven system, and it has hollow fiber membrane and a pre-filter as well. To explain the concept of having high mineral content in the water samples, unlike some of the brands that are available in the market which have very low TDS. So we set up this remineralized RO, where minimum TDS was around 120 to 250, so that sufficient minerals are there in the water for consumption, including the essential sodium, potassium, phosphorus, magnesium, and calcium. So if we give very low TDS water, then all these minerals will be lacked by the consumer, and then it will cause several diseases in the long run. This mask actually we first gave to the HIV positive children, because they were susceptible to the COVID infection. And at the bottom of the slide, you can see in Uttarakhand the atmospheric water generator, and at the center you can see a dialysis water plant, where now about 2 million liters of 2 million patients have been treated by using this dialysis grade water. And on the right side, you can see that we are also making the hollow fiber membranes, and hope to succeed in scaling up and proper certification of the hollow fiber technology. So overall, CSR IICT has installed about 110 installations, and within IICT, which are different plants, not just RO. And so medical grade water plants are there, nanofiltration plants in villages for surface water, pond water treatment, and so on. And we also have a free alkaline ionized water plant running in a Gurdwara, and 8.5 pH is what we specify, not more than that. So within BIS standards only. And it seems to take care of hyperacidity, and also in mitigating joint pains. And you can see a ultra pure medical grade water unit here. So within our campus, we have now actually 25 plants, including medical grade water plants and drinking water plants. You can see the central RO plant for high TDS groundwater. And if we do not use these plants, you can see the number of impurities that get caught in the cartridge itself. And these are visible impurities, and you can imagine the pathogens and the colloidal impurities that can go into our system if we do not treat the water. So this is a free water camp on the airport road. So this is like nanofiltration plant where the TDS is only about moderate TDS groundwater. So we can reduce that 800 TDS to around 350 with 60 to 70% rejection only. And more than 75% recovery of the water. So wastage is less compared to RO. And the reject is used in aloe vera and other crops which are like non-edible for consumption, and quantity of reject is less. So similar such camps are also running in different parts of India, and for not only for fluorosis but also to mitigate fluorosis, but also for pond water treatment, etc. So this is what I was telling about. So upgradation of the existing domestic RO systems. All you need is just two T joints and one needle valve to adjust the flow of the blending water. So the blending water goes through all the pre-treatment steps. If you have ultrafiltration, you can also put that in this line to get rid of the majority of the pathogens. But anyway, we have a UV here, and with two valves, two T joints and one valve, you can enrich the minerals of the RO by 10% of this water to compared to 90% of the RO permeate. Then both together go through UV, and with a low cost TDS meter, which is about 600 to 700 rupees, you can check regularly the TDS of the drinking water being consumed at home, or even in bigger plants this can be provided. And in bigger plants you can also provide ozone, because ozone is 500 times faster than chlorine in disinfection, so it can also be used to treat the water. So this is a technique for remineralizing in existing RO plants. For people who go for newer plants, they can, for especially for municipal water, no need of RO. So this is one such example where existing RO has been upgraded by using this flow sheet that I have shown. And we also have ozone at the end. And this is for school children. And cost is also of the plant is very low, cabinet and skid mounted plant. So we can see the video here. So at least 150 TDS is being given, and ozone is also being given. Yeah, so mostly the R&D aspects are membrane development by different methods. So I will show you phase inversion, how it is done. But other methods, you can read about that. Polymerization for the third layer, which means that you get RO membrane. So phase inversion technique for making the ultrafiltration barrier, and also for the dialysis. Only thing is that though the pore sizes are similar in ultrafiltration and dialysis, the mechanism of separation is different. In dialysis, it is concentration gradient, whereas in ultrafiltration, it is pressure gradient. Okay. And application, of course, we have seen already. We have seen we have gone through reverse osmosis, nanofiltration, ultrafiltration now, and then concentration driven. So for solvent dehydration, as I was telling, like ethanol dehydration, so it is depends on the chemical potential or the volatility of the compound that is being separated. And it is important that all the compounds are volatile when we do pervaporation. And then voltage driven process is electrodialysis. We'll see one case study on that as well. And so hollow fiber and spiral wound are two most commonly used configuration for scale up. However, plate and frame is still going strong, and it is used for electrodialysis especially. It looks like a filter press, and so plate and frame for fuel cell also. It is the form of scale up. So so for students, we can see here that because of affinity, the bigger CO2 or H2S molecule, the impurity comes through biogas or natural gas by applying pressure on one side. Natural gas is already available at high pressure, and you can see that the bigger molecule is coming through because of affinity. Quadrupolar CO2 and polar H2S, they come through because of solution diffusion mechanism, because of affinity based separation, whereas methane is more or less inert. It's a saturated hydrocarbon and doesn't have much affinity for the membrane, and it comes into the retentate side. So here we do not use the word reject, we use retentate. And sometimes, so here in this particular case, the product is the retentate because it is the methane enriched retentate. So that is the what is the product means. It will give us a blue flame from biogas and also higher calorific value, and H2S will not cause the pipeline corrosion if it is removed to less than 4 ppm. Especially in the presence of moisture, H2S can corrode pipelines very fast. So we have to see that the CO2 level is less than 2% and H2S is less than 4 ppm. So, ladies and gentlemen, so you all know about fuel cell now, but still it is expensive and lot of scope for research, especially for making portable fuel cells for laptops, spacecraft, and also for torch lights, mobile phones. So, there we can use membrane because it is solid polymer and easy to carry about. And even for vehicles, we can use direct methanol fuel cell. And here again, oxidation at the anode side will give us protons and electrons, and the protons will move through the membrane which will repel the electrons. It will not allow the electrons to go through. Electrons go through the load, that is the bulb or the the engine of the car. So the electrons will drive the vehicle, and on the other side we allow reduction reaction by providing oxygen from air, and the only byproduct that you can see here in the redox reaction is pure water. So no noise pollution and only pure water as the byproduct. So this will be one of the techniques for the future because it does not need any recharging like a battery, and the efficiency is better than the internal combustion engine. And so porous membranes, so as we can see, like we have been talking about membranes which are opening like ultrafiltration membranes. So if it is single layer, then the molecular sieving, Knudsen's diffusion, and viscous flow and capillary condensation are the mechanisms that will work. And but when I used single membrane to breathe in Delhi for Delhi air pollution, just before COVID, I was not able to breathe. So I thought that it is very tight. So I should have a multiple layer with more open pores. So that is how the mask for COVID came into existence. And for Delhi air pollution, students can work on an activated carbon layer also, which can be impregnated in between, and that can absorb the gases, AD adsorption, absorb the NOx and SOx gases that is prevalent during the smog pollution in winter season of Delhi, when stubble burning and vehicular pollution come together. So other mechanisms, as I already told, for masks, the non-wetting thing like high contact angle and so on. But when there is a single layer ultrafiltration, we can do concentration of antibiotics, proteins, bigger molecule. We can do it by RO also, we can do it by nanofiltration also. But what is the advantage is that lower pressure is required and higher recovery, high throughput, so more open membrane. So bigger molecules we can process by ultrafiltration depending upon the feed that you are like papain enzyme. So those kind of things you can concentrate more easily with higher flux. So the cost will be also less. So here you can see the effect of the lotus leaf like surface. So Young Laplace equation. So the higher the theta, the higher will be the pressure required. So higher the contact angle, the better, or the hydrophobicity, the better for the mask, or even for a technique called as membrane distillation, where hydrophobic membrane is used for desalination of seawater. But if it is solar based membrane distillation, then it is more economical. And the pore radius, so you can see that it is inversely proportional. So the smaller the pore radius, the higher will be the pressure that is required to penetrate that barrier. So we can see now how membrane is developed. And I will show you only phase inversion membrane. And so we can take a dry run. So we have a non-woven fabric here, and polyester non-woven is there here. It is just a support, it will not separate anything. It only provides mechanical support. It is about 100 micrometer thick, and on that we will pour a viscous solution. That is, viscous solution is made of, say, you can say like cellulose acetate in acetone, or that you can dry completely, or you can use polysulfone in dimethyl formamide, or you can use polyacrylonitrile in dimethyl acetamide. So these kind of membranes can be made, and now you are putting it in water. So what happens is that, as per the ternary phase diagram, the plate point is reached when, and you replace the bulk of the water will replace the solvent molecules, DMF molecules. So wherever the solvent molecule is replaced, you will get a small opening or pore. So this is how the membrane looks like. It is an ultrafiltration membrane. It can separate out bacteria, virus, and protozoa and fungi. And so it is safe for surface water treatment, but it will not remove any salt. So it is not useful when we go for groundwater purification. So it allows salts through it. So arsenic fluoride, this will not be useful. At that time, you have to deposit one more layer on top of this. So this is a two-layer composite. At that time, you'll have a three-layer composite that is called as RO membrane, polyamide layer for, and only the reagents for aqueous reactant and organic reactant will change. And depending on that, we get either nanofiltration or even we get RO membrane. We can also coat other membranes, dense membranes on this, because then the solution will not go through the support to the other side. So you can even make gas membrane with three-layer composite or pervaporation membrane with the three-layer composite. So we can also make our own polymers. So you don't have to depend only on polymers that are available in the market. So for some particular applications, you can develop and tailor those polymers. You can even sulfonate them, or you can do amination to give cation and anion exchange membranes as well. So these kind of polymers you can make yourself, and it also can become an import substitute if you make for regularly available polymers also, and produce it in bulk. So you need not, you can have import substitutes on our own, and tailor to our application. So as you can see, silver loaded membranes here. So why silver loaded? Because silver has an affinity for olefins, and it will combine reversible pi complexation with olefin, and then the olefin will transport through the silver loaded membrane to the other side more than the uh, paraffin. So you get good selectivity for propylene compared to propane because of the double bond. And then you might have heard during the COVID wave 2, where we had severe oxygen shortage. So what came to our rescue was pressure swing adsorption. So similarly, you can also have membrane loaded with a carrier for oxygen, means it is called as facilitated transport. Similarly, silver loading is also facilitated transport. So you're using a carrier for one of the components in the feed mixture. So here cobalt thiocyanine will have reversible complexation with oxygen and promote its absorption and diffusion and desorption from the other side. So from 21% oxygen, maybe in one stage you can get 40% or more than that in the permeate line. But you'll have to compress the permeate again if you want higher purity of oxygen. And you can also have CNT loaded membranes or activated carbon loaded membranes depending on your applications. At the bottom, you can see those membranes which are like acid base complexes, which have very good like repulsion of methanol. So there will be no fuel bypass in fuel cells, and very good proton conduction because of this acid base polyion complex. So those kind of membranes also you can have. And we had also worked with the Tata Chemicals in Haldia for PVA nanocomposite for arsenic removal. So these are some of the important equations that the students can remember. So flux, so the volume that is collected per unit area per time. Then rejection, that is 1 minus concentration of the solute or impurity in permeate by the concentration of its concentration in the feed into 100. And then water recovery is direct function of the permeate flow rate to the feed flow rate. And then the permeability coefficient is the product of the flux and thickness divided by the pressure gradient, and in some cases concentration gradient. So you can have those kind of things. And as we have already seen earlier, we also have voltage gradient, voltage as the driving force in case of fuel cell, and it also will be in case of electrodialysis. Selectivity is very similar to relative volatility in distillation, where y for this is for binary mixture, where y is permeate concentration and x is feed concentration of the faster permeating component. These are some of the effect of operating parameters on membrane performance. And unlike what some people may think, pressure can have a positive effect on the solute rejection as well as the flux. whereas temperature can have a negative effect on the selectivity. So you can see propane propylene. So because of the similar molecular sizes and boiling points, it makes the separation very critical. And for propane propylene separation, you need more than 200 days, and you can have. So in the refinery, you can easily make out which is the tallest column. That is for C3 splitter. So to get polymer grade propylene or greater than 99% propylene, so you need more than 200 distillation stages. So you can imagine that. So instead you can do gas separation, and where you have a silver loaded membrane, or we have other membranes like a polyether block amide which has affinity for the olefin. So you can use a different type of membrane, and reduce the number of stages used in the distillation. So here on a smaller level we can test flat sheet. You can see the drawing, or you can see the photograph of the test cell, and it can hold higher pressure also, and it has a central piece perforated plate. On that we keep the membrane, then the central piece will sit on that with an o-ring under it, and then the locking ring. So you can see the pressures on the gauges here and the cylinders. So you can do CO2 methane separation also, and you can also study olefin paraffin separation. So in that way, so you can, if the flow is very slow, you can have a sweep gas to collect the permeate and then inject in GC, or have an online GC as well. So some of the results. So the on the left side you have got PBAX membrane. So one is the cobalt loaded membrane. You can see that the selectivity for oxygen nitrogen is reaching nearly 9, which is a very good sign, because maximum reported in literature is 8 for oxygen and nitrogen, because again, because of the similar properties, it is very difficult, and boiling point is very difficult to separate. And so if you have a carrier loaded membrane, so the challenge is now scale up of these membranes to make it larger scale into spiral wound or hollow fiber modules. So that is the big challenge, because machines in India are suitable for phase inversion and then interfacial polymerization for RO. But for gases, we need to have a dense membrane which is little thicker, at least 2 micron or more, and so you need a proper machinery for that. Now you can see polyimide membranes, they are very useful in gas separation, and here you can see that the hydrogen permeance is much higher. So when you don't know exact thickness, when you make mixed matrix membranes or those on supports, you can use the term called permeance and gas permeability unit. Otherwise the general unit that we use is bearer. And here again you can see the propylene permeate compared to the propane permeate through silver loaded membrane. Again, this is PBAX membrane. These two are PBAX membranes, and they solubilize the silver salt well. That is why we are using PBAX as the substrate, and so that the oxidation state is retained in the membrane, and you have got good interaction with the olefin. And as you can see, the scale is different on the right side. So the selectivity is very high, of more than 40 to 50 is the selectivity. So even a selectivity of 2.5 to 3 for propane propylene is very good. So carbon capture, so we have seen that there are more than 6,000 coal-fired plants all over India, and 55% of the global electricity comes from coal as being the fuel source. And we have seen over decades the rising concentration of the atmospheric CO2, which is causing all the havoc, like climate change. And so we have different methods. So amines are one such source where we can absorb AB now. So we can absorption. So first line you can see absorb. So liquids for gas absorption, and then you can have also ionic liquids. So amines and ionic liquids, and then you can have adsorption, of course. And then so pressure swing adsorption also can be done apart from membrane separation. So when we did natural gas purification at ONGC Hazira in Gujarat, that is near Surat, we tried PBAX and mildly cross-linked it so to get better selectivity. And you can see the plant here. The natural gas itself is available at very high pressure, and you can separate CO2 and H2S from that. Technically it was looked feasible. However, the methane losses are high, so we need to go, and also we need to iron out the defects when casting membrane on a bigger level for gas especially. So still work to be done in this area. So techno economic feasibility has to be established. So if I put another compressor in the second stage, then it becomes an expensive process to recover the methane losses. Biogas again, now here this is from anaerobic digestion of poultry litter done by one of our departments, and we are trying now in the future to enrich the methane by permeating the CO2 H2S. And membrane contactors are going to be one of the future methods for gas separation, including CO2. So you can have amine in the shell side, and you can have CO2 gas in the tube side, or inverse also you can have. Then what happens is, in contact will happen within the pores of the hydrophobic PVDF membrane, or you can try even polypropylene. But for polypropylene membrane, you cannot do solution casting, so you'll have to make it by melt spinning, like a melt extrusion. So polypropylene and polyethylene, they are also hydrophobic. Similarly, PTFE also. So, however, hollow fiber for this is PVDF. We can make my solution casting. So hydrophobic PVDF or hydrophobic polystyrene. So then only there will be no entrainment, and it offers a huge area of for mass transfer of the CO2 or from the feed side into the amine side. Then amine side, then you have to again desorb the CO2 and collect it and send it for production of DME or methanol, or those or other chemicals we have to use, or CO2 as dry ice we can use. So in that way, so this is a gas liquid membrane contactor. You can see a polypropylene module here, and you can see one stream is liquid stream with peristaltic pump, and other is the gas stream. So gas stream now going through tube side, and in the shell side you have got the liquid side, and these are some of the absorption capacities of the amine solution. So here again we must not cross the liquid entry pressure. So flood response and mitigation of water scarcity. So because of the global warming, we also have entire villages washed away some places, whereas in some places we do not have any water at all. Like Jaipur, we have only 15 days of rainfall, and Latur, which it is my dream project to install a plant in Latur. Since from childhood, I was hearing that it has been suffering from earthquakes, water scarcity, and those kind of things. So finally, I succeeded in putting up a plant there. So here, as you can see, ultrafiltration and molecular sieving is the technique. So size-based exclusion. So size-based exclusion. So turbidity will be removed, and pathogens will be removed, but salts and water will be coming through. But in flood water also, you will have low TDS. So this concept I published in 2017-18 in Taylor and Francis, my book that is on membranes. So here I have used that hand pump operated system for interior villages where power will not be there, especially during floods. So only thing is the chlorine cartridge got replaced with this. The chlorine tank for dosing got replaced with the chlorine cartridge. So more easier to leach out some chlorine at 2 milligram per liter, which is sufficient for disinfection. So any secondary contamination, so bulk separation of turbidity and the pathogens will be done by the membrane, and any secondary contamination the cartridge will take care of that. So this is the hollow fiber spinning machine, and you can see the spinneret here at the bottom, and it has two concentric openings, and from the outer concentric opening you have got the polymer solution flowing, and from the inner concentric opening you have got water flowing. So you get a capillary like structure, but it much smaller. So 1.5 mm diameter, and 1 mm is the bore radius. So bore also will have bore fluid, that is mostly water. And so if you do not have bore fluid, you will get a rod like structure. So phase inversion occurs on both sides. So water is there in the tank for coagulation bath, and bore fluid also is there. So you get a porous wall. The walls are porous in this, and if you can shred the fibers into 1 meter long or 1 feet long for dialysis, and then of course if the dimensions are much lesser, and then assemble it into a tube, like a shell and tube heat exchanger. So and then seal the ends, so that there is no mixing of the feed and permeate. Okay, seal the ends up to a long extent, and then cut it off at the very near the circumference of the housing. Okay, then the openings will open up, and you will get the um, membrane. So 8 plants installed in Panamaram, and then in Wayanad district And also we had some help from our sister lab, NIST Trivandrum, who helped us put up a nanofiltration plant at that time in a place where power was there, and Kuttanad and Kottayam also, where we have got collaboration with Mahatma Gandhi University, and there also we had help. And for future installations, we took the help of UNICEF. So 700 liters per hour, and we can see the video of this Amphan cyclone response in Odisha and West Bengal. So this is the module for flood affected areas, and hollow fiber, and then hand pump is being used, and then that is the flood water, and goes through a micron cartridge filter, and then it goes through the membrane, and then you can see the water coming out now. Yeah, so yeah, the chlorine cartridge will leach out slowly, and you can control its opening. And the water is tested nearby, and mostly we are preferring schools now for installations, because it is taken care by the principal, teachers, and the or colleges, so that is more safer. And so we are able to maintain the plants well. So most of the plants, including atmospheric water generator also, we are doing by that method. So this is in Gokak in Karnataka, and you can see here important pH value is within the range, turbidity also within the range, and TDS is quite healthy, 270 in the flood water at the time, and bacteria colonies are zero. That is what is very important. So we should not have any bacterial colonies present at all. So this is the test report at Gokak, and this is of course the summary. And in Assam, yeah. So now we see where there is no water to treat by membrane. What do we do? So the atmosphere offers us a huge resource of relative humidity, and if we consume only 0.001% of that resource, the entire global needs will be satisfied for that particular day. Next day again there will be evaporation from the oceans and other water bodies, and you will get surplus humidity in the atmosphere again. So it is very similar to the AC refrigeration cycle, that is the inverse Carnot cycle. And so for places like Jaipur and Latur, this is very important. And only thing is we have to still bring down the capital investment because of these compressors and the evaporating coil and those things. It's still expensive. So it is like we can see that 1,000 liter per day compared to 1,000 liter per hour for membrane. But still we can fulfill the needs of children and a few hundreds of people in remote areas, including the borders where BSF is working, or the army areas, or the coast guard. So but I would recommend it only for those areas which do not have any water to treat, but and they have, like, some areas have high moisture content, so Himalayan belt and coastal regions, including Chennai. And in Chennai also, in the hospital, cancer hospital opposite CLRI, we have got two plants running there. And then we also can have in places where the water scarce regions, but you have relative humidity up to 40%. So below 25% the unit will shut off automatically. So the principle is suction of the humid air through a pre-filter to remove dust, and then immediately it hits the cold surface. So whenever there is a pressure drop, the compressor will compress the refrigerant R307C, and when you throttle the release the pressure, you will get cooling. So that is what happens in the evaporator coil, and the surface is very cold, and the water will immediately find its dew point and fall into this tank below, where we can add minerals. So if we use rock salt, we can add maximum minerals we can get from that. And food grade soda also can be used with a very very small extent, but rock salt should be 95% or more. And proprietary salt mixture was developed to give all the minerals that is important. You can see bottled water from the atmospheric water generator. So So you can see the model plant here of the atmospheric water generator, and this is how. And we can see also Maitri Aquatech along with Dr. Mashelkar, Dr. Chandrasekhar, and Dr. Arun Tiwari, who are here. And a patent is filed, so all students must their intellectual property they must protect by filing patents. Indian patent is not very expensive; that is only 1 lakh rupees. So you can see the video now, and so this is the tank that will collect the minerals, and two compressors. So this is the so now the capacities have been increased to 2000 liter per day and 5000 liter per day also. But expensive, this 1000 liter per day cost 11 lakh rupees. Whereas 1000 liter per hour membrane system will cost us only 3 lakh rupees. But in areas, that's why we recommend for areas which are water scarce, arid zones. So this is the water coming from air because of the condensation principle. And this is the dosing tank with rock salt and other minerals. But in a smaller capacity for domestic atmospheric water generator, we can have a cartridge. Cartridge will contain ceramic beads that will leach out the minerals. And UV will be given here. And similarly, UV in Secunderabad station, where for visibility this plant was put up. It is called Meghdut, and this is during the inauguration of that plant. Then 15 plants in Uttarakhand in schools where there is no groundwater or municipal water. And this is, I'll just run through this quickly. So you can see first in Adilabad, solar powered plant. So here cartridge is used and not a dosing tank because smaller system 150 liter per day. This is in Darjeeling. So logistical challenges were huge. This is in Latur. This is in Vadji in Maharashtra. Again installed in school, but villages also will have the water. Village people also can have the water in summer especially. And finally in Machilipatnam, because it is a coastal region. Again solar powered. So food and healthcare. So I'll just quickly go through because time is running out. So I'll just show you the system that was installed to make up for the ultra pure water problem in IICT, which was then later converted to for dialysis water also. So you can see two-stage RO, no intermittent pump here. Only by valve arrangement we develop the pressure, and then the reject water we can reuse again for other purposes, and then the resin and UV will follow. And in some places like for dialysis we don't need the resin also. So type 3 water is what we will be using. So that is up to microsiemen 0 to 20 microsiemen or 12 ppm TDS is the maximum, and zero pathogen, zero endotoxin should be there. So useful in automobile industry for battery water, and then microbial culture. So many schools and colleges also for lab grade water. So this is how it looked like in the beginning, and two pumps you can see, and then four membranes, like two in the first stage, two in the second stage, and then resin and UV. So first was Plantris Ventures Private Limited. So startup India and make in India. So again import substitution, and then patent also was filed. So soil test kit they make Plantris Ventures, and they use this technology. Then through Altion Tech Innovations, we signed agreement and we went to Nephroplus hospitals, and we earned some ECF. And Altion Tech also made also was able to get some award, and also they applied for big BIRAC funding through DBT and got sufficient funding. Then when we go below 1 ppm, you have like resistivity range. So you don't have conductivity, so you have resistivity. So some of the water was also used as sanitizer, and you can see a small video of this. And So goes through all the steps, pre-filters, and then you can see here the pressure you can see. And here no resin is given, so you are getting around 2.34. So even distilled water you get 1 to 2 ppm because of carryover, because of entrainment. So now nobody's using distilled water. They come to our lab and collect, or we have got plants installed in IICT as well as in JNTU, CCMB, other CSIR labs also. It is called, should be called as deionized water, 2.35 ppm. So here you can see IoT enabled plant in ESIC hospital. This is first one is in Nephroplus, where now more than 2 lakh patients have been treated, and lesser cost compared to multinational companies that what they offer, and minimum capacity is 500 liter per hour. So you can see TDS is only 0.85. So very low TDS water. So this is not drinkable. It's for medical purpose only, and it will be buffered with salts. If it has any pathogen, then the patient will get affected by hepatitis C. So we have to ensure that dialysis grade water is totally free of endotoxins and pathogens. And flow rate you can see 1700 liters per hour, and IoT enabled. So in on my mobile I will be getting the data. And membranes for dialysis. So as I told, the natural membrane kidney is very selective, and we need to make a synthetic membrane from polysulfone, polyether sulfone for separating the metabolic toxins from the blood into the dialysing fluid through the pores openings by concentration gradient. So very fine spinneret is used here compared to what I showed you there. The diameter will be 1/5. Both the diameters will be 1/5 of what I've shown. So you can see very fine fibers here. And this is the spinneret, which has a pin, detachable pin, because later when the polymer gets solidified or choked, it's difficult to clean. So we'll replace the pin. And modules are being made and potted on either side for sealing. And so this is how the dialysis module is made. And we are also planning to make the epoxy adhesive also indigenous, so that we can avoid imported polyurethane. This machine is made by CSIR Chandigarh, and we can see the testing of this module by goat's blood. Actually we wanted to avoid, but this is like from the butcher shop we had to take to do a test. But later we will be doing in vivo trials on the animal, and the animal will recover within 2 months at NRCM, National Research Center for Meat. And then we also will need some certification from other agencies for clinical trials. So first on animal. So here you can see not a single blood droplet is coming through, and dialysis is going on. And we have spiked the blood with extra creatinine and urea. And you can see the dialysing fluid is collecting the urea and the toxins, and the dialysis period is somewhat shorter. However, doctors have advised that we should not go below 3.5 hours for per dialysis operation, so to avoid any fluctuations in the blood pressure in the patient. The main thing is to make it cost effective. Again, import substitute. So you can see no coloration in the dialysing fluid, only transfer of metabolic toxins because of concentration gradient occurs. So alkaline water, I will not go too deep into this. I will just say that we are trying to make a more cost effective model, because our clients are still selling at high price, like 95,000, 75,000, still cheaper than Kangen water. But two benefits only we have seen so far. One is, and we recommend pH not higher than BIS standards, 8.5. So more research is required. So 8.5, see, it is reducing hyperacidity and joint pains. So transfer technology. So one good thing is 8 to 8.5 pH in Gurudwara, free of cost in Rajouri Garden in New Delhi. So jointly installed by micro engineers and ourselves. IC Pure is the model name. Then hydroxyapatite concentration for dental care for a doctor, Mr. Dr. Vivekanand in Guntur. Then stevia as a sugar substitute. So this here also membrane is used for removing the impurities like high molecular weight as well as salts, and then evaporator and crystallization. Then enzyme clarification and concentration by membranes, ultrafiltration membranes. Then lycopene isolation, and along with storage at in the refrigerator. So you can enrich the lycopene bioactive compound in watermelon juice. Similarly, if you have UV and ultrafiltration, we know we can do aseptic packaging without adding any chemicals as preservative. That is the objective. Then we'll see one case study of the industrial effluent before going to the last video on the COVID mask. So pharma effluents contain all kinds of impurities, so unreacted molecules, salts, organic solvents. So this one case contain organic solvent which is used as the medium for making antiretroviral drug DMSO. So sodium azide is highly explosive, so highly susceptible to impact. So it is 2% on an average. So we cannot distill the liquor. Ammonium chloride is also corrosive, and remaining is water. So if we send it to for ETP, huge costs for removing the DMSO by aeration, and very difficult to do by anaerobic, so it will not work. But all the bacteria will get killed. So we have to do some other method. So DMSO is the medium for making the drug, anti-AIDS drug, zidovudine, and sodium azide is the catalyst. And so electrodialysis, like we have seen in case of fuel cell, but only thing is that we have got multiple chambers. Every alternate chambers, the feed will be sent. You can see here, and you will give a distributor which will be tightly packed, so that one key kind of arrangement will be given in the distributor, and you will get the feed solution in alternate chambers. Sodium ion will move towards the cathode. Ammonium, the azide ion will move towards the anode. Why they cannot come back is because of repulsion from the cathode. Sodium azide ion cannot come back because of the cathode repulsion, and sodium ion cannot come back to the dilute chambers or feed chambers. So in this way, the concentrate another and the other alternative chambers will have water collecting the sodium azide and ammonium chloride. And so now we have desalted liquor which can now be distilled. So electrodialysis, we have three solutions. The third is, so one you have seen as feed, one is that is called as dilute later, and one you have seen as concentrate which collects the salts. And we can also do deacidification, not only salt removal but de-alkalization and deacidification also, like HCl removal from glyphosate herbicide, those kind of applications also. So any ionizable compound from non-ionizable product we can remove. And third solution is for electrode rinse. So it will be flowing at the ends. There will be no physical mixing of any of these three liquids. Only ion transfer will happen when we apply DC potential, and entire medium is conducting. No air gap is there. Membranes are conducting, and these solutions are conducting. And we have got electrodes, so preferably titanium coated with titanium oxide coated anode, and plain titanium cathode we can have. If you want to do electrode reversal, then both have to be coated, so that anode is the sacrificial electrode. Students can remember that. So electrodialysis and then distillation. So first stage, so you can see electrodialysis stack here. First stage, the water is removed from the distillation column as the first cut, and second cut DMSO is removed under vacuum. So vacuum will bring down the boiling point and will remove the DMSO from higher boiling color forming organics. And this DMSO has met the drug specifications. So 7,500. So on a smaller lab scale level, we demonstrated. You can see the electrodialysis stack here. Looks like a filter press, and the key will be given wherever the distributor is there in opposite direction, so that alternate chambers will collect dilute, and the other alternate will collect concentrate, and the ion only will be moving. And so you have got bigger stacks here in the industry, so designed and like a filter press. And at the ends, only thing is that there is voltage terminals here, so to give DC power to make the separation happen through the anion and cation exchange membranes. So 30 metric tons of DMSO was recovered by the industry. Similarly, decolorization of effluent. So nanofiltration allows monovalent salt to pass through and rejects bivalent salts. So we have allowed the thiocyanate to pass through the nanofiltration membrane of 250 molecular weight cutoff. So sodium thiocyanate is the solvent for the fiber. It passes through the membrane and rejects the color forming impurities like calcium, iron, and other contaminants, and bigger organic molecules also. And this colorless solution is blended with the main solution, so no losses of sodium thiocyanate and effluent treatment at the same time. Tata Steel, so they do not have a very stringent requirement for chloride separation in the coke oven. So coke is used for making steel. So coke oven, after quenching, the effluent that comes out will be rich in chloride. If you send back the same water, then the oven will get corroded and the pipelines will get corroded. So we remove the chloride to an extent of only 75 to 80%, and send back 500 ppm is acceptable. And so from 2000 to 500 we bring down. So 100 molecular weight cutoff nanofiltration, so tighter nanofiltration. So this plant is running successfully since 2017, 8 years. And water recovery is very high, 85%. and the 15% reject is treated by sodium aluminate, and the decanted water again goes back to nanofiltration, and the sediment is used in paint industry. So this we already discussed for banana and other flavors, watermelon and those flavors. So energy applications, so students can work on isolation of lithium or sodium ion batteries coming up. So we can do isolation of those, or magnesium battery also, and magnesium for food application also. So you can see that there is a small cell here, and we have got this membrane electrolysis, not electrodialysis, electrolysis. So single slice membrane. So, and then you have got anode and cathode, and then magnesium starts moving from its heptahydrate salt to the other side, and then if we don't get any white precipitate on the other side, that means chloride is not coming. So you can see, yeah, so you can see this is by silver nitrate test and enriched feed solution. So magnesium rich solution, chloride rich solution. So we have separated the ion. Now magnesium hydroxide or magnesium can go for food application also. 800 chemical reactions in the body is carried out by magnesium. Magnesium in ionic state is absorbed better by the body. So fuel cell based cars, so acid based complexes. So I think I have exceeded my time limit. So mechanism of transport will be jumping mechanism and by H3O plus mechanism. So this is a very good power density, 1 kilowatt per meter square, similar to Nephon. And that is the point, like we want to have a low cost substitute for Nephon membrane, which is around $1,200 per meter square, I think, at the moment. And students can also work on cheaper catalyst compared to platinum ruthenium. So per evaporation, one side vacuum and one side atmospheric pressure. If we do on a continuous level, we can remove the product like ethanol, and then it can go for distillation, which will be concentrated. But the ethanol will inhibit the enzyme. So if we continuously remove ethanol by per evaporation, then we can increase the yield. So air separation we have already seen. Then another problem that is coming up is semiconductor industry. So like ultra pure chemicals without any metal ions, because metal ions will make the silicon wafer into a conductor. So we need ultra pure chemicals. So fluoride removal, I have told you about that. Then this is nanofiltration for pond water, which students have been drinking continuously. And now after nanofiltration, you can see ozonator here. UV is also given, and the reject is sent back to the pond. Now this is in Gandhi Hospital, and again nanofiltration. But we have to be careful here because huge chlorine is dosed, and so we add sodium bisulfite or sodium beta bisulfite to reduce the chlorine concentration. Otherwise, it will damage the polyamide layer. And patients are very happy, and what do you call, the assistants to the patient also, attendants. So they are getting free water here in Gandhi Hospital. The reject of the nanofiltration system can directly be used for washing utensils or into the restrooms or laundry and other villages exhibitions. And then I gave an article which stated that RO water we should not drink. It should have a bypass line, so remineralization. So in this context, we converted the RO membrane into nanofiltration membrane by opening up the pores using hypo. Hypo will slowly degrade the layer. So half an hour of treatment, and here we have signed up with Permionics and vertical modular system. So this is packaged drinking water. Just to set an example, here our most tough was to get the ISI mark and the FASI certification, and NABL for water analysis. So this is Remenero, sold well through petrol pumps, and we would like to again revive it because there is some GST problem right now after COVID. And innovation to combat COVID. So I'll show you face shields we gave free of cost, and this is the 4-layer mask with 2 hydrophobic layers at the center, and washable mask. There are no stitches at the center anywhere, so it is, otherwise that needle will create a small opening through which also droplets or the can escape, very fine droplets can escape. So these are the advantages, and it is having that 3D shape. So this is the video of that. So this was the initial shape, polypropylene layer, PET layer, and you can have any type of cotton on either side. Cotton is just for comfort and for dust filtration and for aesthetics also. So air permeability should be high compared to N95. So air permeability, so it should be breathable. So 2.2 times more than N95. But water permeability should be low because it has to repel the droplets. So water permeability was only 37%, one third of N95. So good repulsion of water droplets, respiratory droplets because of the hydrophobicity. How to make out whether the mask is working or not? So flame blow test. So if I am unable to blow out the flame, that means respiratory droplets are not coming out and my mask is safe. Now you can see the lotus leaf effect and the pressure that is required by the Young Laplace equation. So you can see respiratory droplets sitting on a very thin layer, just a 20 micron layer. So 1 lakh masks were distributed free of cost to villages, schools, hospitals, NGOs with the help of Sifla Foundation, which came forward and funded part of the project. And then another part, the NGOs transfer at a low cost. And so after that, 6 lakh masks were sold by 5 NGOs, including Helpage India, Mandeshi Foundation, and then we have got Ambuja Cement Foundation in Himachal. So pan India basis. So we are, and even in Bihar we have Helpage India. So in that way, a revenue of 2 crore was generated for the NGOs, and the employment of 500 senior citizens and women self-help groups was brought about. And we also made a device for doctors and dentists, and we also made UV chamber and a special solution for disinfection. Eco-friendly ventilator from car wiper pump also was made, and air purifier is still valid because of Delhi air pollution, and we are looking forward to do something more in this area for the tackling the winter and at a low with a low cost solution. However, an air compressor will be required and that will consume some energy. So lab development, wherever I have gone, I have tried to do that. Even when I went to Australia, because our students may not have the particular facility, so I carried pumps and modules and membranes and flat sheets, everything there to Australia. And so we don't have to use RO everywhere. It is only used for desalination, and for high TDS groundwater you can use, and ensure the TDS that you are having is quite sufficient, 120 to 350 ppm. Taste also should be good, that's why 350 ppm, otherwise you can have 500 also. And so scale up of gas separation per evaporation membranes is a challenge which we need to overcome. Hollow fiber membranes offer a good solution to this. And RO reject treatment is very important, and reuse instead of disposal, I would say. And so there is still belief in imported devices, but we have so many Indian made products which are better, so we should try to trust those things. So one challenge that R.M.D college and others can take up is COD reduction in pharmaceutical effluent. So this is a very tough challenge, and also the effluent from leather industry, so tanneries, so that is also tough. So there is hesitation of industry sometimes to induce changes, like in petroleum industry we have safety also is important, that is why. So we are, our process should be safe and economical. So future plans, so I will be going to Andaman next week and seeing whether we can put solar powered RO there, solar operated RO for desalination. And there is also another idea for direct air capture of CO2 from air, and use that CO2 for like greenhouse gas for crops inside. So that is one more plan. And then hydrogen valley mission is there, and white hydrogen suppression, it is from natural crust of the earth, white hydrogen is there. Then BHEL IIP project is also there for membrane and PSA integrated processes. So MBR for STP is also there and in the plan of works, and anaerobic and aerobic both may have to be used to for the STP. And safety is very important, so I request all students to take care So every time teachers also cannot remind, and we also cannot remind. So you have to take care of your own safety and also advise other students. So wear aprons, goggles, and gloves whenever you are working with chemicals. Always follow the safety norms and try to do maximum any hazardous equipment. Try to do in the few mode. So thank you to one and all to all the viewers in the YouTube as well, and to RMD College for patiently listening to my lecture. So like to thank you, and I will stop sharing so that.
Thank you so much, sir. It was mind blowing, sir.
Thank you, madam.
Yeah. Yeah.
Thank you, sir, for enlightening our knowledge with your words of wisdom and inspiring us with your dynamic session. No wonder the presentation was extremely inspirational, and all our students must have been carried away by the insightful thoughts and the research experience shared by you, sir. We have a couple of questions from our students. Can we selectively continue, sir?
Please, please.
Yes, sir. We have a question from M. Roshini of first year ECEC, sir. She is asking, how can we add essential minerals to an existing RO plant without reducing the water quality?
We can have a mineral cartridge at the end. We can have a nowadays it is available in the market, ceramic beads. So mineral cartridge, it gives a little bit of alkalinity also, but we can add that. And the other method is, of course, as I have shown, that we can use the blending technique, so that the flow sheet can be showed to the operator. So that is why I presented that flow sheet where you can have the blending line. Just he needs some tubing, two T joints and push fit T joints, and one valve to control the flow of the blending line. So in that way, the RO water can be enriched. Another is adding a cartridge at the permeate side to get more minerals, but better to test the TDS always. So ask the operator to show the TDS whenever he is coming, and check that. And it is not very expensive, so I think everybody now can afford to purchase the TDS meter, and once in a while get the water tested in a lab for pH also.
Yes, sir. Okay, sir. Thank you, sir. Sir, we have another question from Sriram of first year ITC, sir. His question is, how about developing a membrane technology in controlling air pollution from vehicles, sir?
Yeah, it was there. Actually, there was some thought going on about some catalytic converter that will be put in the silencer of the vehicles. But at the same time, it should not reduce the output or the flow of the vehicle. We could have some kind of a cartridge or something in the silencer part, which will, but mostly an absorber. And but the flow of the air should be free. That also has to be taken care of, and the adsorber should also take care. And then once again you need to regenerate the adsorber and reuse it again. So we need to use some adsorption technique in this context, but it's a very good idea and very good research problem to work on. So maybe a cartridge based adsorption or a flat sheet based adsorption which has activated carbon and some other adsorbents which will take up the SOx and NOx and carbon monoxide and CO2 also.
Okay, sir. Thank you, sir. We have so many questions here, but due to the time limit, we shall
Yeah,
limit
I
ourselves to
can
questions.
take two more if required. So
Okay,
if there
sir.
are,
Like the question is, could the recovery of rare metals from e-waste using membrane techniques create a new economic sector in India? Is it possible?
yeah, it's possible. But first, the pre-treatment of that e-waste is very important to extract that those things into aqueous solution. Once it is in aqueous medium, then we can use membrane. So how to leach out those rare earth elements from that problem the student can look into. But once it comes into aqueous solution, then it is easy. Even by RO we can concentrate because it's heavy metals. Even by nanofiltration we can concentrate it because their molecular weights are high. So it's a very very important and good question. And the first part of how to break down that e-waste and then get a solution of those metals in aqueous media, then after that we can isolate them by membranes.
Okay, sir. Thank you so much, sir, for patiently answering all our questions.
Sir, once again, sir. So we would like to have a two more session, one on adsorption separately and distillation
Sure,
separately.
sure.
Two more session we may need, sir. So
Sure, ma'am.
please
Sure.
spare your time for us. uh, particularly with this vehicular pollution, sir. Yeah.
Sure, madam.
Thank
We
you.
will have we'll have those sessions, and yeah. So because we also have ACSR classes regularly for our PhD students who are now registering with ACSIR. So we can have on whatever
Okay.
topic in separation techniques, whatever in advanced separation techniques is one topic that I am teaching along with membrane technology. So in that context, we
Sure, sir.
can have more interaction. Definitely, ma'am.
Thank you, sir.
Thank you,
Thank you,
thank you,
sir.
thank you, madam.
Thank you, sir.
So once.
Thank you.
Appreciation is a wonderful thing. It makes what is excellent in others belong to us as well. On behalf of the Department of Science and Humanities of R.M.D. Engineering College, I deem it a great honor to propose the vote of thanks on this important occasion. First and foremost, I wish to take the opportunity to express my immense gratitude to our management of RMK Group of Institutions for their vision, commitment, and encouragement in organizing such knowledge enriching and innovative learning programs for the benefits and welfare of the student community. I sincerely express my heartfelt thanks to our principal, Dr. N. Anvicharian, and Dean Research, Dr. K.K. Tyagarajan, for their continuous support, motivation, and guidance for the smooth conduct of this program. I express my profound thanks to our head of the department, Dr. T. Tamilshelvi, for her words of encouragement and valuable guidance. It's really a great privilege and honor to thank our guest invitee, Dr. S. Sridhar, chemical engineer and scientist, CSIR, Indian Institute of Chemical Technology, Hyderabad, for his innovative talk on the learning system that exists currently. The session was really engaging and extremely purposeful, sir. My heartfelt thanks to the heads of various departments and the faculty members for their valuable contribution, guidance, and encouragement. Finally, I thank all our students for your active participation and wonderful cooperation throughout the program. Thank you, one and all.
Thank you,
Sir.
madam. Thank you very much. Thanks to RMD, and hope to interact again in the future. Thank you, madam.
Sure, sir. Thank you, sir.
Thank you.